Hey guys, welcome to Math Monday. So if you're at home today watching this video, this is your instruction video. I always try to keep them as short as possible so you don't have to watch a super duper long video. Once you are done with this, you will do the homework page that goes along with the video. So for you guys that were there on Thursday, I went over what's called prime factorization in class a little bit. So watch this video even though we did some in class, because it will help you the more that you see it and practice it, because it's kind of a hard concept, but don't worry because practice makes perfect and we'll get there. So first off, I'm going to take a picture of a couple of things that I want you to copy down into your math notebook. Again, if you did not bring your math notebook home, that's okay. Still do it on a regular piece of paper that then you can glue into your math notebook when you get to school. That way you can still do it and don't think, oh no, I didn't bring it home, I can't do it. The first one I'm going to show you, but don't worry, you can either pause the video and copy it down, or I'm going to take a picture of it and put it in Google Classroom. So in your math notebook, you're going to write this down because it has the most common prime numbers. At 2:35, we went to 7-Eleven to buy 13 Slurpees for $17.19. So all of those numbers in there, 2, 3, 5, 7, 11, 13, 17, 19 are prime numbers. And again, a prime number means that the only factors or numbers that you multiply together that will go into that number, the only factors in a prime number are 1 in itself. So like the number 7, we can only get to 7 by multiplying 1 times 7. There's no other smaller numbers that will go into 7. Okay, and the second one, again, either pause the video and copy, or I will take a picture and put it in Google Classroom. This is just your definition of the difference between a prime number and a composite number. So a prime number, this is telling you that 17 is a prime number because only 1 and 17 are factors. So only 1 times 17 go into 17. No other numbers can be multiplied smaller than that will go into 17. However, composite, 15 is an example of a composite number because it has more factors than 1 and 15. What are other factors? Well, 3 and 5 are factors because 3 times 5 equals 15, not just 1 and 15. So make sure that those go into your math notebook. The other thing that goes into your math notebook is this. Most of you tore it out when we were in class. This thing here, if you can fill out the trees, it's a little foldable thing. Put that in your math notebook too. So let's start the lesson, and we're just going to go over prime factorization again. Let me see. I need to figure out how to prop up. There we go. That's okay, right? Kind of. Let me put it closer. And that way you can see it. Color's not good. I need to have some kind of a better, I don't know, studio or something for recording, don't I? Okay, so here's my whiteboard. We're going to go over a couple of prime factorization trees. They call them trees, but I think that they're more of a pyramid because you start and you have the big number up top that you start with, and then you branch out underneath so it looks like it's the shape of a pyramid rather than having branches up here. So let's start with a number. In your homework assignment, let me see what is the first one that you do, and then that way you can do that one along. So 50. So in your homework page 85 and 86 that you'll do at home, the number 1 is 50. So I'm going to write it there. It goes at the very top. Okay, now remember what we do is we want to find two numbers that you multiply together that equal 50. Not addition. Remember how I said this is not, prime factorization is not for addition. So don't do, oh, I know, 25 and 25, because 25 plus 25 is 50. Remember, no addition. What I can do though is I can say 25 times 2 is 50. And remember how I also said it does not matter if you choose different numbers than this. If you decided to do 10 times 5, it doesn't matter, you get the same answers at the end. So 25 times 2 goes into 50. Now we need to keep going and see if we can break apart these numbers until we get prime numbers. So I'm going to look at 25. Can I break 25 apart between two factors? I can. I happen to know that 5 times 5 is 25. And if it helps you, you can put the times sign. What about 2 though? Can I break 2 apart? No, I can't. Well, I mean, I can, 2 times 1, but that's the whole point of this, is we're finding the prime numbers. 2 is prime. Remember our little poem at 235? So because we found one of the prime numbers, I'm going to circle it. And then 5 and 5. Now, can we break these guys down? Can we break down that 5 or that 5? No, remember 5 is also a prime number. So we're going to circle them as well. And you can either write this is your answer, because now we have only prime numbers left. You can write your answer as either 2 times 5 times 5. We're just writing all the prime numbers down that can go into 50. Or, remember I showed you on that color page that we did, if you have 2 or 3 or 4 numbers that are the same, like I have 2 5s, instead of writing 5 times 5, I can do a little exponent. I can put a 2 up there. 2 times 5 squared or to the second power, because 5 2 times is the same as 5 times 5. So I can either write it like this or 2 times 5 times 5. Okay, let's do one more. Hopefully this is kind of making sense. We're going to start doing lots and lots of multiplication table practice, because here's the deal. In the next 2 chapters, we do multiplication and division a lot. And if you have forgotten all of your times tables, like 5 times 8 or 7 times 9, if you've forgotten them, it's going to take you a long time to do multiplication and division. So we're going to try and rememorize everything, okay? Let's do number 2 together. Okay, the number is 81. Now, we don't use calculators in math. However, if you ever have a huge number on here, like for example, the next one is 65. In fact, maybe we'll do that one. And 65 is hard because it's hard to think of numbers that go into 65 because it's not on the 1 through 10 times table chart. So if you have to use a calculator to find other numbers that go into 65, that's okay. I'm going to try a couple because I'm not sure what goes into 65. I have a feeling that goes into 65, and we'll go over long division again, don't worry. 5 goes into, we start small, 5 goes into the first number 6 one time, then 1 times 5 is 5. Now I subtract, 6 minus 5 is 1. And then I bring down the next number, remember? I bring down that 5. Now I divide again, 5 into 15. I know 5 goes into 15 3 times. So I have my answer, it's 13. So now I know that I can break 65 down into 13 times 5. Now let's see if we can break apart those two numbers. Are there any numbers that we can times together that equal 13? No. If you are thinking that that was in our little 7-Eleven rhyme, you're correct. 13 is a prime number. The only numbers that go into it are 13 times 1. What about 5? Are there other numbers other than 1 times 5 that go into 5? There's not. So we found our 2 prime numbers. So literally this is just going to be 5 times 13. It doesn't matter if you write 13 times 5. It's just they want you, when you write your answer, to always start with the smaller numbers and then go to the bigger numbers. So that's it. That's what the prime factorization is for this. I'm going to stop there, and I'm going to let you do the rest of your examples. If you have questions on the homework assignment, which is 85 and 86, bring it to class, and you can ask me during math work time, and then I can help you. Okay, all right. I will see you Tuesday. Bye, guys.